Welcome, everybody. Thank you very much for joining us for this little CanCOVID Roundtable with myself, Dylan Roskams-Edris, and Rachel Harding. We'll introduce ourselves in just a second, but I wanted to quickly bring up that this is supposed to be a discussion. This is supposed to be a roundtable. So if anybody has any questions or interests or requests for clarification or anything like that, please feel free to put it in the chat, which I'll be monitoring, or just to kind of raise your hand, turn on your video, and ask away. There's a lot of topics to cover in open science, and there's no possible way that we can cover them in half an hour. So I think we shall begin. Rachel, would you like to start by just giving a quick little spiel about yourself?
Absolutely. So hi, everyone. Thank you so much for taking the time out of your day to join us. Hoping for a lively discussion. My name is Rachel Harding. I'm a research fellow at the Structural Genomics Consortium, which is based at the University of Toronto. My work is primarily based on Huntington's disease, so I actually work in neuroscience, but I do a lot of work in the open science space and thinking about how we can better communicate science through different open science policies and strategies.
Cool. And my name is Dylan Roskams-Edris. I'm the Open Science Alliance Officer for the Neuro, which is an Open Science Institute. If you want to learn more about that, please feel free to go on to theneuro.ca. And my job essentially is to talk to people, to neuroscientists, but generally scientists in Canada, about open science, whether it's wanting to become an open science institute or doing one more little thing you can do to make your science a little bit more open. As such, I've got a relatively broad knowledge about what open science is all about. And Rachel's the actual researcher who's been engaging in open science practices like sharing open lab notebooks, which if you search up SGC, Open Lab Notebooks in Google, you'll get a couple of examples. So with that, we wanted to first do a little bit of what is open science? And this is one of those questions that's really hard to answer because there are a whole bunch of different potential answers to that. While avoiding any particular definition, a good kind of rough and ready definition is the rapid and barrier-free dissemination of all the inputs and outputs of any given piece of science. This is greatly facilitated by the internet. The internet and computers really is what made open science a reality. And where by rapidly disseminating information, you can allow others to remix, reuse, rebuild upon, create downstream innovations and discoveries. Is that?
I think that's a good brief introduction. But yeah, so this kind of covers all aspects of the sort of scholarly communication workflow, from the moment that we stop doing our experiments to how we then communicate all of that information to the various stakeholders. So one of the other aspects that's really important about open science is that the target audience is not necessarily just your traditional audience. By making things open, one of the main sort of pillars of open science is you're creating a more equitable society by reaching out to all kinds of different folks. So whether they're people in policy or funding agencies, academia, or other the general public, open science is accessible or should be accessible to everyone.
Yeah. One good example for that at the Neuro is patients.
Yes, absolutely. So that's something I think people, in the context of COVID-19, the patient community is essentially like everyone, the entire general public, and that's something that's a really critical aspect to think about when communicating open science policy for COVID research.
Okay.
So, sorry, Dylan.
No, this is going to keep happening. We both like to talk.
Yeah, no problem. So some of the things that we wanted to cover today are the fact that one of the first things that anyone in our community could observe was that as soon as the COVID outbreak began, one of the first things that started happening is that we had the beginning of like a lot of the research that was being done was immediately communicated using open science practices. And this covered all sorts of different things, between the sort of sharing of data prior to traditional publication, as well as the rapid growth in the number of preprints and other kind of research outputs that were being shared openly. And I'm sure many of you are familiar with the way that repositories such as bioRxiv and medRxiv have been inundated with all of these like very exciting manuscripts hot off the presses to to share with the wider community that are telling us about the latest and greatest COVID research.
Okay, and the next thing that we were going to cover actually directly relates to a question that we just received from Diane Finegood, which was, how can we balance open science for scientists and misrepresentation of findings by the media and others? Because obviously this is something that's been happening with the rise in the number of preprints that, as just one example, that have been released. Sometimes they get picked up by media and says, you know, this is the hydrochloroquine is the be all and end all, or actually it's going to kill you, or something along those lines. And it turns into a partisan debate that really doesn't dig into the science itself. So there are a couple of things that have been done. One being relatively rapidly, preprint servers like bioRxiv and medRxiv ended up putting a little disclaimer at the top saying, this is not peer-reviewed work. Please do not use it as evidence of an established fact in media or anything along those lines. So that's one thing that we could potentially try to do. Another thing, which Rachel was pointing out earlier, is active communication between scientists and policy makers and news outlets and so on, so that instead of having them just searching through preprint servers and looking for exactly the preprint that backs up the point that they want to make, the partisan point that they want to make, by actively engaging with stakeholders through anywhere, through things like Twitter. You can direct the conversation, or at least point out evidence that says this or that is not correct. And just educate people about, for example, what the heck a preprint even is, because the average public or the average reporter doesn't necessarily know that a preprint is not the same thing as a published article.
Absolutely.
Anything to add to that?
Yeah, I would say that there's definitely a lag in the education of journalists and perhaps other science communicators about what these different research outputs are and where they fit in the research pipeline. So, you know, most of us on this call are aware of what a preprint manuscript is. If you're not, it's the version of the manuscript that you submit to the journal publisher that's not yet undergone any peer review, external peer review necessarily. That means that, you know, whilst, you know, we may have great trust in the findings because you know that scientists and you know the sort of rigor by which they do their work, there is still, you know, critique that needs to be done ahead of the final publication. But I think one thing that has really kind of, an idea that's really sort of highlighted itself to me in the last few months is that, you know, peer review is not, and this is something Dylan said earlier, peer review is not a final process. You know, we never read scientific manuscripts and accept everything that's in it as 100% facts. We're always critically analyzing the way that research is published. And, you know, I've never sat in a journal club where someone said absolutely everything in this manuscript is top notch and 100%, you know, great and really well done. There's always points of contention. And I think that's fine. And it's just an understanding of the limitations of the different research outputs that both scientists and other people in science communication probably are sort of catching up with when they're having to deal with these different outputs. Dylan, you're on mute.
Indeed. And another thing that we've seen is what's being called science by press release. And this is something that Rachel was talking to me about earlier, where instead of releasing, you know, the actual data or a peer-reviewed publication about some new intervention when it comes to COVID, they have some preliminary results from a trial that a company will then keep secret, and then have a press release and say, look, we have some amazing preliminary results, which then ends up doing things like boosting stock prices and so on and so forth. So educating people about those kinds of activities and how they don't fit within the normal scientific practice in the way of self-correction within science is another key component. It looks like Diane Finegood has her hand up, so please ask away.
Yes, I do have my hand up. So I guess, you know, in thinking about this, I was thinking about open science as being much about the structures that we need to change being much deeper than just educating the public about what to believe and what not to believe, or what to pay attention to. And we need space in science to encourage people to work across boundaries, which I think CanCOVID is starting to help us do. But there's so many structural impediments in the form of perverse incentives against this, that to really make change, to really have true open science, we need some structural change in our academies, for example, like valuing publications in certain journals and all of that. I've been asking this question about how we change that for a long time. And, you know, peer review by media, or what, I can't remember how you called it, but, you know, we've been doing this forever, in part because there's an incentive to get your university incentivizes you to get your stuff in the paper. So the idea of getting your stuff in the paper too early is one of the many structural problems that we need to fix. I don't think it's just about education.
Agreed.
Yeah. I think there's some really nice examples, however, about some of the preprints which have been submitted, which are clearly erroneous and contain misinformation or just incredibly poor science, have been retracted or heavily critiqued through social media platforms and other blog platforms in a way that I think is quite unusual for traditional manuscripts. And we've seen that happen a lot. You know, when one of the things that's quite interesting about the way that bioRxiv has adapted to COVID-19 is that everyone is suddenly working on COVID, and everyone's now a COVID research expert. And you now have not just your 2 or 3 peer reviewers at your whichever journal you send it to, you have the 1,000 people who've downloaded your manuscripts and are now tweeting about it. And it's kind of a very interesting and kind of democratizing approach to how we review scientific research. And it's for sure not perfect, but there is a nice kind of self-correction about some of the more extreme examples of the poor research that's being done.
So,
yeah, do you think we're uncovering more bad research because the culture is shifting in this way? Like, you know, we all have had our experiences of getting rejected by stupid reviewers, or in our opinion, stupid reviewers. I mean, I just was looking at a response to a paper that we submitted where we got one reviewer and they loved us. And this is the second journal where we had one who hated us and one who loved us, right? You know, so peer review is, as they say, peer review doesn't work. It's just the best thing we have, right?
Exactly.
Well, I'm not so sure. I'm not sure that's true.
well, peer review is, so there's a couple of things that I want to say about this. One is, you're right, peer review is absolutely not infallible, right? It's a lot more about, is this article appropriate for this particular journal, rather than saying, is this research completely and utterly infallible over the long term? And one of the ways that we're seeing that in the COVID context is the retractions that have happened recently, for example, the Lancet. So this is an example that I like to bring up a lot, because it went through, you know, they said, yes, this is absolutely fine. And then it came out that the data upon, or at least a portion of the data upon which the claims were based, this is that hydrochloroquine and chloroquine were actually dangerous, were not shared publicly, but they weren't even shared with the other authors of the paper. So there was no way for the public or even the other authors to validate that the results actually emerged from the data. And this data was being held by a private company, Surgisphere, that then said, we can't release this because of various business interests that are involved. And this made it through peer review. So this is the kind of thing where if you really want to change how science is communicated in a way that maximizes replicability and reproducibility, it means that you have to change how we disseminate information, how much information is disseminated, and looking well beyond the kind of outmoded idea of just sharing results through publications.
Yeah, to your second point about more global structures in academia being sort of the barriers for open science, I have to agree with you that I think the fact that so many job positions and other promotions and so forth are entirely based on impact factor values of different journals rather than the sort of rigor and quality of the science being done by individuals is going to consistently be a barrier to open science being adopted in the mainstream. And I think that's something that a lot of open science communities are working on. How do we catalyze on the momentum that surrounds open science in the COVID-19 research space and expand that beyond and into other disciplines? You know, open science practices have existed for a long time in very specific fields and very specific silos. But now, you know, how do we expand that to help, you know, accelerate discovery and overcome a lot of research barriers to find new medicines for other diseases that have traditionally been incredibly competitive and sort of shielded in secrecy. And, you know, you go to conferences and you see posters with protein X with compound Y and nothing's actually disclosed. And, you know, these are the kind of problems that are facing. And, you know, I think it's an exciting time because I feel we're definitely at this turning point, but how we keep moving forward, I don't think is necessarily clear yet. And I think conversations like this and engagement with different communities is going to be one of the ways that we get momentum and hopefully get input from, you know, funders and so forth, who are the people holding the purse strings and can drive change, in my opinion, at least.
Okay.
Oh boy. The funder, I mean, I'll just say, I was an inaugural scientific director for CIHR, and I'm not sure CIHR has progressed far enough in the past 20 years to get its head out of the funding approach sand. And I'm not sure researchers would let them. So, you know, when I was a scientific director, I'll just make one quick comment and then leave room for others. We did a study about a review of panels, and we separated the sort of basic science panels from the sort of clinical and or basic science and clinical together with social and population health. And they clearly mark them differently, but the review panel, the guy who did this piece of work said, you know, the scores are so tight that we should actually just use a lottery system. Take off the top 5% because you can figure out the really, really best stuff. Take off the bottom, you know, 15 or 20% if you can pick out the really crappy stuff. And after that, it's a lottery, because it's a lottery anyways. It all depends whether you're after lunch or before lunch or, you know, in terms of grant review. But can you imagine our federal government funder saying, okay, we're going to do it this way, and we're going to fund those by lottery? I love the idea. It makes perfect sense, but
yeah,
making
You'd
that
have
happen,
researchers storming the gates.
I spent more than a decade leading health funding organizations, and it ain't going to happen. Not anytime soon.
Yeah.
But there are researchers
would storm the gates.
But there are research funding organizations like the Wellcome Trust, like Chan Zuckerberg and others and Gates, for example, who heavily support open science initiatives. And actually it's a prerequisite of, you know, of taking any of their funding that you have to publish openly, you have to show your data, you have to do all these things. So it's not outside the realm of possibility. It's more that there's kind of a sort of historical reasons that people just don't like change, right? So it's okay for these people to be leading the field, but for our national institutions to be doing that is something that's slightly different. But I think that's why actually this executive order that apparently Trump may or may not sign, which seems entirely bizarre to me, about the changes to NIH embargoes and the open access on that is really, really interesting, because this is clearly something that for whatever reason he's decided is a Republican issue, and is, you know, goes across the line of party politics, that actually open science is good for everyone. And I never thought I would agree with President Trump on many things, but this appears to be one of those moments. But yeah, it's very interesting to see what will happen with that, at least.
Okay, I've got more things to say, but there are some people who are asking questions in the chat, so I figured we should bring those up. First one from David Moore: we are too hard on peer reviewers. There's no training for it. Can we really expect folks to do better without training? This is not something that I traditionally talk about in terms of open science, but I think that makes a lot of sense. Rachel could probably talk a little bit more about training. I think another thing that we can do is try to make sure communities, research communities, organize so that when they do share, you know, the software and the data and the protocols that are underlying a particular paper, it's done in a standardized format that makes it really easy for someone to be able to go in and say, oh, here's your data, let's apply that software to it. Oh, it actually generates the results. As opposed to now, sometimes you share your data and your software and it's in such a strange and esoteric format that a reviewer would have to spend 5 hours just learning how to use the piece of software to be able to actually validate it. Setting those kinds of community standards to ease sharing and review of one another's research is a key component of what open science is all about.
Yeah, I think another thing is that part of the value of open science is that we value different research outputs, whether that is your peer review comments and the work that you put in to writing these and critiquing other people's science, that is something that's helping fostering, a healthy science ecosystem. And so I think that, perhaps if we change the way that we approach peer reviewers and that we, give appropriate deadlines and appropriate input and help from editorial boards, then perhaps that will change. And there are actually a number of journals who are doing various things to open up peer review as well. So for example, like eLife, and there's a number of other journals that require like signed peer reviews, which is quite interesting as well. So there's definitely something that a lot of journals are experimenting in this space to see, what is the best way to do this.
Which I think speaks a little bit to Diane's point from before, which is we can't just rely on the funders changing things. It relies on funders changing things, institutions changing things, journals changing things, everywhere along the pipe to be able to have this structural change that actually encourages open science, because it's going to happen. It would just be really great if it didn't have to wait until the people in the younger generation who have been sharing things online rapidly and openly for our entire lives ascended the ladder into the power positions. If the groundwork could be laid right now, it would be fantastic. Okay, 1 point from David O'Brien in the chat. What you did see in the CIHR COVID calls was an open data by default requirement, and that is a change. That is a change, absolutely. These kind of little incremental requirements are going to be key.
Absolutely. Yeah, just a reminder to everyone, if you have any questions, to just pop them in the chat window. So one of the things that's also been interesting is, which I think Dylan can probably speak to more, is the sort of intersection of open science in the COVID space and therapeutic development, and how that links in with IP and the way that you do or do not file patents on various things when it's considered an open science output.
I absolutely can. I don't want to take too much time about this, though I admit it, I went to law school. And what I was particularly interested in studying when I was there was the interaction between the science generated in academic institutions and intellectual property. And what I tended to find is that the most good that researchers can do is to share openly and rapidly. That's exactly why I got into open science, because if you actually start digging into the numbers, the attempt to lock things up through intellectual property coming out of public organizations, it's not the most efficient way of making sure that useful information gets disseminated and used for the greatest social and economic benefit. I'm not going to go way too much into this unless someone would like more, but one interesting effort that I would encourage you to check out if you're interested is the Open COVID Pledge that was put out, that a whole bunch of industry actors, including IBM, Amazon, Facebook, a whole bunch of different tech companies, agreed to sign a pledge saying all of our patents are made available on free and open terms to anybody who wants to use them for the purposes of developing diagnostics or therapeutics for ending the COVID crisis. This is the kind of thing where these companies are admitting, okay, instead of having to negotiate all these little licensing agreements, which also ends up impacting the ability of researchers to send, reagents or materials to one another because of the IP clauses in material transfer agreements, they said, we know that this can get in the way, so we're just going to release it all, and now anybody can use it for whatever purpose, as long as that's towards the end of ending the COVID-19 crisis. If anybody wants more information on IP, please feel free to raise your hand or ask a question or anything along those lines. Yes,
Sarah.
Looks like Sarah Gallagher.
Yeah, Sarah Gallagher. So I just wanted to offer perspective. I'm an astronomer. So we've been doing open science for like 30 years. And honestly, some of these conversations are baffling to me as I don't get them. Yeah. So I just want to share a little bit so the culture in astronomy is very different, and the landscape of how funding works and everything. Basically what happens is, in order to make it big advances in the field, you need to have multinational, multi-institutional investments in really expensive facilities. And then there's an expectation, whether this is space missions or ground-based observatories, and then there's an expectation, which initially I think actually was started by NASA, that data after a certain point would become freely and publicly available. And then there have been a lot of studies of what the impact is in terms of research output for those. And by far, the greatest impact is in the archives. So the Hubble Space Telescope, for example, it's been up there since the early 90s. The more publications, more impactful publications have come out of the archive than the original publications. And so there is a lot of very concrete data that the science impact is greatly aided by open science, and that and also just enables much more science. And so I think there is data that can support it by principle in very sort of concrete ways that exists for, you know, maybe not within biomedical fields, but certainly in other fields.
Yeah.
I
Absolutely.
mean, one of the things that got me into open science was reading the book Reinventing Discovery by Michael Nielsen. And I was particularly captured by his discussion of the Sloan Digital Sky Survey, which is, I think, one of these examples where when you share data, and this was a fascinating example because it's not just sharing data with other researchers. They set up a platform that would allow citizens to come on and help try to identify different types of galaxies and make identifications of observations. And you're right, it has absolutely been the mainstay in a number of different fields, including like physics and economics. Sorry, did you have a follow-up? Okay, sorry, I thought I saw your thing turn off. It is 1:30, but I'm willing to stick around if anybody else is interested in doing so. And I guess I'll just stick around until anybody else who wants to ask a question or anything along those lines is able to do so.
There is a question from Kimberly in the chat. So we mentioned earlier that some funders have requirements that if they fund you, that you have to adhere to various open science principles. And the question is, are there academic institutions that are making similar requirements? And so actually Dylan and I both work at institutions that do this. So I work at the Structural Genomics Consortium, which is a public-private partnership that has an open science policy mandating that we publish all of our manuscripts through preprint servers like bioRxiv or preprints.org, and you know, we share our data and we don't file for patent on things. And Dylan is also working at a similar institute, which is the Tannenbaum Open Science Institute, the TOSI, based at the Neuro at McGill, which has a similar open science policy as well, and is actually helping other institutes become open science institutes. But beyond those very Canadian focused efforts, I'm not sure that there are actually many other completely open science institutes that adhere to open science policy as a sort of mandated policy beyond a lab by lab basis.
Yeah, it's mainly.
I would love to know of more examples, but yeah, if anyone knows of any.
We have one comment from Dana McFarland saying, talk to your scholarly communication librarian for more info. And I cannot stress this enough. This is what librarians are for. Librarians have a scholarly and like professional history stretching back thousands of years about the organization and dissemination of information. So these people are experts. Don't try to like reinvent the wheel. A lot of different institutes, including McGill, will have, you know, here's how to do open access publishing, or here's how to create a data management plan, tutorials and web pages and all of the above. So please, like, capitalize on these institutional resources that already exist and the knowledge that exists there.
And I think from having attended a series of open science conferences, nearly every major Canadian university has an open science librarian or a scholarly communication librarian whose specific job it is to help researchers make their research openly available to wider communities. So there are like even more specialist folks within the infrastructure of the university who can help you do these things. And they're generally the most lovely people who are really excited to help academics open up their research and answer any of your questions on copyright and other aspects of the sort of legal bits and bobs of doing open science. Kimberly?
I'm the program manager of CanCOVID, so I'm not a researcher or a scientist myself. But one of the things that I keep hearing about is people expressing that researchers need to have a motivation that is not the larger altruistic serving the common good. So I would love it if you could speak to why, like, what would personally motivate you to do open science, and what are the benefits that you could see from that, or that you've experienced yourself?
Well, I would say that there's an obvious financial one for obtaining grant funding. So there are a number, as I alluded to earlier, like there's a whole coalition of research funding groups called the Open Research Funding Group, ORFG, led by Spark. And they basically mandate open science policy if you receive funding from them, but also in the application that you make, their requirements aren't just like, we want to see X number of manuscripts with a certain impact factor, or these kind of publications. The kind of impactful research outputs that they're looking for are actually very often things in the open science space. So when I've reviewed things for the Wellcome Trust before, it could be things like they want to see a data set that has been reused 1,000 times, even if the paper is in a journal with a impact factor of 3. That's not important. The thing is that someone used your research that many times, and therefore you're having an impact within your field. So I think that is something that's slowly evolving. And it seems like institutes like CIHR and so forth are also pushing that way. The other thing I would say that other funders who are really interested in the open science space are, that from my personal experience, are patient-based charities who fund research. So one of the best things for especially like rare disease research, or sort of smaller charities that fund sort of small pockets of research, of which there are so many in Canada, they really like to see open science practices because it gives them really good return on their investment. So they're not just funding someone to do some research that may never see the light of day. You can mandate that all the data from that project be made available, and all the reagents that are generated in that project are also shared. And that's been my experience of working with Huntington's disease charities from both the States and also in Canada, that they are really keen to see open science policies. And we've received lots of really positive feedback from them that these are the kind of things that we're including in our research plan. Because for them, it's great because they can show the patients and other stakeholders and donors of their charity like where their money is going in a very obvious and tangible way. And I'm sure that's true for other research organizations as well.
Yeah, and the only thing that I would add to that is, you're right, there are a number of different motivations that exist within science, not just around altruism and, I want to help the world. One of them Rachel just touched on, which is reputation. Another is solving hard problems. A lot of scientists get a real, what drives them is attempting to solve this really hard problem, uncover this particular mystery of the universe. And we're getting to the point now that a single person working in a single lab, or even a single lab, simply is not able to solve in biology the complexity of all of the interactions of single protein. So if you really want to do that, to do it effectively, you need to engage with a community globally that's working on that. And like what was mentioned earlier, in the same way that COVID doesn't respect international borders, open science shouldn't be respecting international borders either. Part of the point is to develop this global research community where anybody interested in working and solving a problem can apply their micro expertise to say, actually, have you seen this? Or here's this bug in your code because you shared the code with me. Or here's an artifact in your data that for some reason, you weren't able to pick up before. And here's a solution for filtering out that particular artifact. So there's a real utility component of it as well, as long as you find the right community to get involved with, which you just kind of have to search around.
Absolutely. Great. Are there any further questions? So Shannon's just put in the chat window that there is encouragement by the different federal organizations to encourage you to immediately share all your data and your publications. So this is definitely a step forward, but is not quite as far along as some of the open research funding groups that we've heard about today, where these kind of things are mandated. And also this only applies in the context of COVID-19 research, not other research at the moment. So that's where there's the kind of missing gap, I think. But I think this is something that's definitely on the road to being changed, at least. It seems quite promising.
Agreed. Is there any more questions that people are interested in answering? Sorry, I'm just trying to field some of the questions in the text here too. So if anybody has anything else, pop it in the chat or ask us live, or if not, then feel free to contact.
Wrap up. Yeah. We
can wrap up, or feel free to contact Rachel and myself independently. So just as the
and don't forget that you've got an open science channel on the CanCOVID Slack to continue.
Indeed, which I will keep checking on.
Fantastic.
Okay, well, I think what we've talked to you about today is there's a whole bunch of different things that we covered. But what we were trying to do for you is show how it's been really important for COVID that data, protocols, papers and whatnot have been shared, and I think that that's pretty demonstrably true, that there are some worries about the rapid spread of information, for example, the misuse by media, and that the lessons that we're learning about open science have been applied before in other fields, as we saw in astronomy that Sarah was talking about earlier, are getting applied within fields like biomedical research, with which Rachel and myself are concerned, and have the potential to impact any number of different scientific fields, because really open science is just science done faster. And as long as you engage with your community and expand that sphere to the entire globe, we really have a chance of, you know, improving the way that science is done. It's going to take a lot of work, but I think it's worth it.
Excellent. Thank you, guys.
All right, I'm just going to stick around for a second here to answer some questions in the chat, but thank you all very much for attending.
Excellent. Alrighty, I think we're done.
Yeah. I think that went pretty well.
That was fantastic. Thank you.
Yeah, I enjoyed that.
Yeah, me too.
Someone's asking me in the chat about different sources of data about COVID, so I'm just rapidly looking around trying to figure out.
Who was that?
I think I can download a log so that you can.
Yeah,
that would be very much appreciated.
I think when you stop the meeting when it's recording, it automatically saves all the chat window.
Yeah. I'll send it to you.
Perfect. All right, I'm gonna have to go.
Perfect.
Okay, you good luck on finishing.
Thank you both so much.
No worries. Thank you very much for organizing.
Yeah, this was a lot of fun. If you want any more engagement at any point, more than happy.
Absolutely, I will be in touch.
All right.
Fantastic.
See you guys soon. Bye.